So what is exactly corona and why it is happening? If you see, suppose this is a conductor and there is a current, or we can say electrons are flowing through this conductor. This is a conductor. So whenever this current flows, there is a electromagnetic field around this conductor, right? So the electromagnetic field near to the conductor is or that field density is more than the away from the conductor. इथे जर आपण कन्सिडर केलं की व्होल्टेज ग्रेडियंट इलेक्ट्रोस्टॅटिक फील्ड जर कन्सिडर केली सो व्होल्टेज ग्रेडियंट नियर टू द आता असं म्हणूयात की आपण ही 400 केवीची लाईन आहे so nearby conductor the electrostatic field it is nearly let us suppose here it is 300 kV whenever we are going away it will be 200 it is 100 kV so whenever we are moving towards or away from the conductor this voltage gradient near to the conductor or away from the conductor it gets decreases जसं कंडक्टर पासून लांब लांब जाणार आपण तसं काय होणार ते इलेक्ट्रोस्टॅटिक जे व्होल्टेज ग्रेडियंट आहे it is going to decrease. So what is happening exactly? If we consider air, you know that air is a dielectric material. Okay, means it is not a good insulator also we can say. So if we consider air, this air is having dielectric strength of 30 kV per centimeter. हे सगळ्यांना माहिती असेल and this is not means what is the dielectric strength of air? It is equal to 30 kilovolt per centimeter. What do you mean by dielectric strength? Yes, anyone? But this dielectric strength, it is in normal temperature and pressure. See, particularly the air consider केली at normal temperature and pressure, we can say that dielectric strength is equal to 30 kV per centimeter. Let us say suppose this is spare gap arrangement. Okay. And at normal temperature and pressure with this distance it is equal to 1 centimeter. If we are going to maintain these standard conditions and the potential difference between these two electrode it is equal to 30 kV per centimeter. So this air inside this spare gap it will get ionized, right? And some noise, cracking noise, it will get produced over here. Okay, so it means what? Whenever at particular normal temperature and pressure, whenever there is a 30 kV per centimeter potential difference between 2 points, that air get ionized and cracking noise takes place. So same is happening in case of transmission line. If we consider this conductor and it is having near about 400 kV line, at every distance, at here it is 400 kV, let us suppose here it is 300 kV, here it is 200 kV. So some potential or voltage gradient takes place near conductor, and if that voltage gradient increases above 30 kV per centimeter, that nearby air it get ionized and it forms or it tends to that air it should be in conduction. So the effective conduction area of that conductor it get increased. लक्षात येते का? And it leads to cracking noise and some violet color glow nearby that conductor, and that particular glow or that particular uh, effect is called as a corona. Now, why it is happening and whether it is always present nearby that conductor or in specific condition only. So yes, it is present in case of we can say when there is a lot of humidity or moisture around that conductor inside the air. म्हणजे हे रेनी सीझन मध्ये काय होतं की बऱ्याच वेळा बाष्प किंवा मॉइश्चर एअरमध्ये असल्यामुळे it will become more conductive, means that air become more conductive and with less voltage that corona offers. Okay, so there are some conditions, means which are the conditions to occur the corona is nothing but the, means there are, we can say, suppose the conditions are, first one is a descriptive critical voltage. So what is exactly descriptive critical voltage? So it is nothing but the minimum voltage in any weather condition. This voltage is going to change according to the weather. It is minimum voltage required to air ionization. So we can say that the minimum voltage at which air get ionized is called as a critical descriptive voltage, and generally it is denoted by VCR. Okay, its nomenclature for this voltage is VCR. Let us suppose right now I have just explained you one example. At that case, it is 30 kV per centimeter. But if we consider the overhead conductor which is carrying high voltage supply, at that time, at critical voltage, it may leave, means according to weather condition, it may increase or it may decrease also. Again, second condition is visual critical voltage. As I told you, what is critical descriptive voltage? It is nothing but the minimum voltage required to air ionization. And see, generally in every situation or every condition, whenever you are observing the overhead transmission line, that corona, it is not visible. In rainy season, in stormy weather, it is visible. So we can say what is visual condition for corona. So let us suppose it is nothing but the minimum voltage. Visual means it can be seen by us. We can say that critical or visual critical voltage, it is nothing but the minimum voltage required to corona glow. And this visual critical voltage, it is different according to different weather condition, right? Let us suppose we'll consider that ECR is equal to 30 kV per centimeter. So in that case, it may be, means visual critical voltage, it may be 50 kV per centimeter. Have you got these 2 points? What is critical descriptive voltage and visual critical voltage? Yes or no? Okay. So which are the factors which affects the, we can say, corona, right? So what is happening? Right now, you know that corona, it is nothing but that means whenever that air get ionized, it becomes conductive, and the effective conduction area of that conductor get increased, and generally that corona is occur on the sharp edges of insulator on conductor. And generally what is happening means suppose this conductor is, it is not having uniform shape, and dust is deposited or particular strand, it is broken. So at that time means at this particular location generally corona occurs or that visual glow occurs. Or if we consider the sharp edges of any tower or conductor insulator, at that edges that corona is generally occurring. So there are different factors which are going to affect the corona. The first one is, let us suppose, factors. First one is atmospheric condition. See, in case of, as I told you, visual corona means visual corona voltage, it is nothing but the minimum voltage which is required to corona glow. करोना कधी दिसेल एखादा पर्टिक्युलर व्होल्टेज असेल की ज्या मिनिमम व्होल्टेजला करोना आपल्याला ऑफ जर आपण करू शकतो पाहू शकतो. जर रेनी सीझन असेल तर ते जे व्हिज्युअल करोना व्होल्टेज आहे ते इन्क्रीज होईल का डिक्रीज होईल? येस, एनीवन? इन केस ऑफ रेनी
Increase
सीझन,
weight.
आर यू शुअर?
Yes, sir.
रेनी सीझन मध्ये काय होतं? मॉइश्चर इन्क्रीज होतं. जर मॉइश्चर असेल तर एअर जास्त कंडक्टिव्ह असेल की कमी? हां, मग जर कंडक्टिंग असेल, कारण की मॉइश्चर कंटेंट म्हणजे व्होल्टेज आहे व्हिज्युअल करोनासाठी ते इन्क्रीज असणार आहे की डिक्रीज असणार आहे? किंवा असं डिक्रीज होणार आहे, राईट ना? सी, स्पेअर गॅप कन्सिडर केला आणि इथे जी एअर आहे, इथे जर मॉइश्चरचं कंटेंट जास्त असेल, नॉर्मली आपण म्हणलं 1 सेंटीमीटरचा डिस्टन्स आहे आणि स्टँडर्ड टेम्परेचर आणि स्टँडर्ड ॲम्बियंट टेम्परेचर कन्सिडर केलं, आपण स्टँडर्ड प्रेशर कन्सिडर केला, तर हे जे ब्रेकडाऊन व्होल्टेज होतं ते 30 kV पर सेंटीमीटर आहे नॉर्मल कंडिशनला. बट इफ देर इज अ मॉइश्चर प्रेझेंट इनसाइड this air, so what will happen? This voltage is less than the 30 kV, right? The same way, the visual critical voltage, it will also get decreased. So due to atmospheric condition, the visual critical voltage it decreases, right? This is decreases due to rainy condition. So if we consider rainy weather, whether corona loss is increases or decreases? रेनी वेदर मध्ये करोना लॉस जास्त असणार का कमी असेल? यस, yes, it will get increased. So corona loss increases. If we consider normal weather condition, comparatively, corona loss is lesser. Now, this is one of the factor, that is atmospheric condition. Second is line voltage. So can you tell me, if line voltage increases, corona increases or decreases?
Increases.
Line, yes, line voltage increases, it leads to corona loss or increase in corona loss. But see, line voltage increases means what we can say, electrostatic field increases. Electrostatic field increases means what will happen? The ionization will increase and it will lead to, as I told you, the loss of corona, increase in loss of corona. But see, to reduce the losses means why we are going for extra voltage? Can anyone tell me what is the reason we are going for extra voltage? Right now we are just seeing the factors which are affecting the corona. Okay, so the second factor is line voltage. It is straightforward that line voltage increases means what will happen? Electrostatic field near to the current conductor, it will increase. See, this is conductor. The electrostatic field near to this conductor, it will get increased, and if it is beyond 30 kV per centimeter, means that we can say electrostatic field between these 2 points, if it is increases, let us suppose this is conductor, one strand is broken, and if we consider these 2 points, okay, and the distance between these two is less than 1 centimeter, or we can say nearly 1 centimeter, and in these 2 points, if that electrostatic field increases rapidly or it is having very high value, it will get ionized, right? So same thing, when line voltage increases, electrostatic field increases and it will lead to higher corona loss. But To reduce the losses of transmission, we are going for higher voltages, right? And to whenever we are going for higher voltages, to reduce only corona loss, we can't decrease the line voltage. Means it is mandatory one. But generally, corona is occurring near about voltages which is about 254 or 250 kV. म्हणजे 250 kV च्या वर जेव्हा व्होल्टेज येतं तुमचं लाईन व्होल्टेज तर त्या केसमध्ये जनरली corona is observed. So second factor is line voltage. So as I told you, line voltage increases, electrostatic field nearby conductor increases, and it will lead to increase in corona loss. Next point, third one, it is nothing but the nature of conductor surface. Okay, so there may be two conditions. One is a non-uniform conductor surface. And uniform conductor surface. So in which case loss is more and in which case loss is less? Yes, anyone? What will be in non-uniform conductor? The corona loss is whether it is more or lesser. And what are the reasons? See, what is happening? We can say that whenever corona is there, let us suppose this is conductor, and when air nearby this conductor get ionized, it forms ozone gas. Okay, and that ozone gas produces acid. म्हणजे आता इथली जी एअर आहे सराउंडिंगची ती एअर जर आयोनाइज झाली तर आयोनाइज झाल्यामुळे इथे काय होतं इट मे लीड्स द प्रोडक्शन ऑफ ओझोन. म्हणजे ओझोन प्रोड्यूस झाला दॅट ड्यू टू दॅट ओझोन सम ऍसिड विल बी प्रोड्यूस नियर बाय दॅट कंडक्टर on that conductor, and due to that acid this conductor get corrode. corrosion होतं आणि त्याचे जे किंवा त्या कंडक्टरचा जो सरफेस आहे तो असं म्हणूयात आपण कधी तुम्ही जर्मन किंवा ॲल्युमिनियमची भांडी वगैरे बघितली असतील त्याच्यावर ऍसिड किंवा कुठल्या हे झालं की त्याचा सरफेस एकदम असा रफ होऊन जातो. सो ड्यू टू सच कंडिशन ड्यू टू करोना and that acid produced due to this ozone gas, this conductor surface will become rough or non-uniform, and due to non-uniform conductor surface the loss of corona or corona loss increases. If that conductor is uniform, the loss is lesser. So generally we are going for aluminum or ACSR, aluminum core steel reinforced किंवा triple AC, all aluminum alloy conductor. So in that case the loss is lesser. So make sure that the conductor surface is uniform, otherwise it is going to affect the corona loss. The fourth factor is effect of frequency. So as you know that the corona loss is directly proportional to the frequency. The frequency increases, the loss due to corona is increases. The fifth one, air condition. Just before 2 minutes, we have discussed about what is the effect of air condition. If there is a rainy atmosphere, the conductivity of air it get increased and it leads to increase in corona loss. So these are the factors which are affecting the corona. So how to reduce this corona? Actually, let us see how to reduce it. Can anyone please tell me? Anybody knows how to reduce the corona? Conductor spacing. So we can use bundle conductor. First is a spacing between conductor, very nice. And conductor diameter. So by increasing the conductor diameter or by increasing the spacing between conductor, we can decrease the corona. Means in so many cases, in case of extra voltage AC supply transmission, they are using bundle conductor. By using bundle conductor and increasing the spacing between two adjacent conductor, the corona loss is decreased. Okay, so how to decrease it means why this conductor spacing decreases. See, in previous unit we have seen the voltage gradient. So if you consider the bundle conductor voltage gradient, in that case is very less, and it leads to uh, decrease in corona loss. Second point, see, operating voltage increases means what will happen? Corona increases. So by decreasing the operating voltage or reducing the operating voltage, see, operating voltage reduce झालं म्हणजे काय होईल? Ionization reduce होईल. But is it practically possible to reduce the operating voltage? Is the corona loss होऊ नये म्हणून operating voltage reduce करायचं? Yes, definitely operating voltage reduces means what will happen? Electrostatic field around that conductor will get reduced and it will reduces the ionization and similarly the corona loss. But it is not practically accepted solution because to reduce other losses we have to go for higher voltages. See, by reducing operating voltage we can reduce the corona loss, but it is not proper solution. Third one is use of corona ring. It is at the both the end of the conductor and it reduces the uh, see it is having uniform shape and it reduces that electrostatic field which causes the corona loss or it cancel out that effect. Okay, if not seen yet you can see in images also or whenever you are going to visit the substation you can observe at many places that corona ring is uh, installed to reduce the corona loss. And the fourth one, the use of bundle conductor. See here, right now we have seen the conditions for corona formation. So there are two conditions. One is a critical descriptive voltage and visual critical voltage. What is critical descriptive voltage? Minimum voltage required to air ionization. Then what is visual critical voltage? It is nothing but the minimum voltage required to corona glow and for a standard temperature condition and atmospheric condition that critical descriptive voltage it is equal to 30 kV per centimeter. After that we have seen which are the factors affecting on corona in which the first one is atmospheric condition, second one is line voltage, third one is nature of conductor surface, fourth one effect of frequency and fifth one air condition. And after that we have seen how to reduce corona. There are four factors which are spacing between the conductor and conductor diameter. This is generally means used. Second is operating voltage. It is not used because we have to go for higher voltages. Use of corona ring and use of bundle conductor. So these are the standard methods to reduce the corona. Again, see, we are seeing corona loss, corona loss. Whether this corona is having any advantage, advantages of corona is it reduces the transient effect. So what is exactly transient effect? See, due to some switching condition, transient means what we can say overcurrent, lightning मुळे transient occur होतात. So this corona it causes the reduction in transient effect. That is, there is a reduction in surge on the conductor. Means lightning झालं एकदम lightning stroke आला. तर ते lightning stroke corona lossच्या फॉर्म मध्ये reduce होतो. So this is one of the major advantage of corona. Second is in case of corona, this air is act as a virtual conductor. So with advantages, there are some disadvantages also. Which are those? The first one is losses increase होतात म्हणजे काय होईल? Yes, loss increase झाला म्हणजे efficiency काय होते? Reduce होणार आहे, right? Second, as I told you, due to corona, ozone gas is produced, and this ozone gas leads to production of acid. It produces acid, and this acid it causes the corrosion of conductor. So what will happen if that conductor is corroded? Its mechanical strength will get decreased. Again, strand break होतील, conductor break होण्याचे chances वाढतील. And the third point is it causes the production of third harmonic. So whether this third harmonic is good for transmission line or bad? Yes, please. Again, it is produces some bad effect on transmission line. We are going to see in further lecture. So these are the disadvantages of corona, in which first one is due to corona reduction in efficiency. You know that losses increases means efficiency decreases. Again, corona. See, in previous example also, I told you that ozone gas it produces the acid, and which causes the corrosion of conductor, due to which more corona is produced, causes the production of harmonics. These are the some disadvantages of corona. Now, let us say suppose we'll consider that EC. This EC is nothing but the actual voltage or actual voltage gradient or voltage trace, and it is measured in kilovolt per meter. Okay, and generally it is in instantaneous, or we can say RMS value. And if we consider this kVp, it is equal to root 2 times kVm. This is nothing but the peak value, and this is not, sorry, RMS. This is maximum value. So actual electric field strength, voltage trace, or voltage gradient in air of conductor, it is in kV per meter, and this depends on the voltage of conductor, or we can say on conductor diameter, or we can say the field distribution. So if we consider ECR, this ECR is nothing but the critical electric stress, or you can say that what is it is critical descriptive voltage. It is nothing but the field strength, or we can say the minimum value of voltage gradient at conductor surface at which the air get ionized, right? This is conductor, as I told you, if it is carrying 400 kV supply, the nearby, as we are going away from this conductor, this here it is 400, 300, 200, again 100. So it get decreases. So if we consider just nearby point of conductor, this ECR is nothing but the critical electric stress or the minimum value of voltage gradient at conductor surface at which it get ionized, that air get ionized and corona discharge begin. And generally it is in kV per meter. So where kV is nothing but the instantaneous value of voltage or current, sorry, instantaneous value or RMS value. And what is ECR? It depends on, yes, critical descriptive voltage कशावर depend असतं? It depends on weather condition, or you can say depends on surface condition. So there may be two cases in between EC and ECR. Let us say suppose for this EC is nothing but the standard or actual voltage gradient. If this EC is greater than ECR, see what is ECR? It is nothing but the minimum voltage which is required to get air get ionized. आणि जे ऑपरेटिंग व्होल्टेज आहे EC हे ECR पेक्षा जास्त असेल तर corona occur होईल का नाही होणार? It will get occur. Corona occurs, and if this EC is lesser than ECR, what will happen? This corona is negligibly small and it can be ignored. Okay, so as I told you, when the surface voltage trace, that is EC, it exceeds this critical voltage or critical stress ECR, then corona, visual corona begins, and the corona increases with increasing the conductor voltage and with poor voltage condition or weather condition. जेवढं जास्त bad weather असेल like rainy season आणि जेवढं जास्त कंडक्टरचं व्होल्टेज इन्क्रीज होणार आहे तेवढा तो corona वाढणार आहे. Okay, we'll stop here. Thank you so much.